VLANs and trunking. VLANs, virtual LANs, and trunking are important concepts in networking that are used to logically segment networks and efficiently transport VLAN traffic across multiple switches or devices. Here's an overview of VLANs and trunking. VLANs, virtual LANs. VLANs are used to logically segment a single physical LAN, local area network, into multiple virtual networks. Each VLAN acts as a separate broadcast domain, allowing devices in different VLANs to communicate with each other based on their VLAN membership. VLANs are typically configured on switches, and devices within the same VLAN can communicate with each other as if they were connected to the same physical LAN, even if they are physically located in different parts of the network. Advantages of VLANs. 1. Improved network security. VLANs allow for the isolation of network traffic, preventing unauthorized access and limiting the potential impact of security breaches or attacks. 2. Better network performance. VLANs can help optimize network performance by reducing the amount of broadcast traffic and allowing for more efficient use of network resources. 3. Enhanced network management. VLANs enable easier management and configuration of network devices, as well as improved troubleshooting and monitoring capabilities. 4. Flexibility and scalability. VLANs provide flexibility in network design and allow for easy scalability as network requirements change over time. Module 3. Routing technologies. Routing fundamentals. Routing is a fundamental concept in networking that involves the process of forwarding data packets between different networks or subnets. It allows devices in one network to communicate with devices in other networks, even if they are located in different geographical locations or connected to different types of networks. Here are some key fundamentals of routing. 1. Routing tables. Routing tables are used by routers to determine the best path for forwarding data packets. They contain information about the network topology, including the network addresses and associated routes, and are used to make decisions on how to forward packets to their intended destinations. Routing tables can be statically configured or dynamically learned through routing protocols. 2. Routing protocols. Routing protocols are sets of rules and algorithms that routers use to exchange routing information and dynamically update their routing tables. There are various types of routing protocols, including interior gateway protocols, IGPs, and exterior gateway protocols, EGPs. Examples of IGPs include Routing Information Protocol, RIP, Open Shortest Path First, OSPF, and Enhanced Interior Gateway Routing Protocol, EIGRP. Examples of EGPs include Border Gateway Protocol, BGP, used in the Internet. 3. Network addressing and subnetting. Routing is based on network addressing, which involves assigning unique IP addresses to devices in a network. IP addresses are used to identify the source and destination of data packets. Subnetting is a technique used to divide a large IP network into smaller, more manageable subnets, which allows for better network organization, improved security, and efficient use of IP address space. 4. Routing metrics. Routing metrics are used to determine the best path for forwarding packets based on various criteria such as the shortest path, fastest path, least congested path, or most reliable path. Common routing metrics include hop count, number of hops between networks, bandwidth, delay, reliability, and cost. Routing is a complex and critical process in networking that enables devices in different networks to communicate with each other. Understanding the fundamentals of routing, including routing tables, routing protocols, network addressing. Routing protocols, RIP, OSPF, and EIGRP. Routing protocols are used in computer networks to dynamically exchange routing information among routers, allowing them to automatically update their routing tables and efficiently forward data packets to their destinations. There are several routing protocols commonly used in modern networks, including RIP, Routing Information Protocol, OSPF, Open Shortest Path First, and EIGRP, Enhanced Interior Gateway Routing Protocol. Let's take a brief overview of each. 1. RIP. Routing Information Protocol. RIP is a distance vector routing protocol that uses a hop count as its metric to determine the best path for data packets. RIP is a simple and widely used routing protocol, commonly used in small networks or as a legacy protocol in older networks. However, RIP has some limitations, such as its slow convergence time and limited scalability, as it does not support advanced features like variable length subnet masking, VLSM, or route summarization. 2. OSPF. Open Shortest Path. First, OSPF is a link state routing protocol that uses a cost metric based on bandwidth to determine the best path for data packets. OSPF is a popular and widely used routing protocol in enterprise networks, as it offers advanced features such as support for VLSM, route summarization, and fast convergence. OSPF also supports hierarchical routing, allowing for efficient scaling in large networks. 3. EIGRP. Enhanced Interior Gateway Routing Protocol. EIGRP is a Cisco proprietary routing protocol that combines features of both distance vector and link state protocols. EIGRP uses a metric that takes into account bandwidth, delay, reliability, and load to determine the best path for data packets. EIGRP also supports advanced features such as support for VLSM, route summarization, and fast convergence. EIGRP is commonly used in Cisco networks, but it is not interoperable with non-Cisco devices. It's important to note that routing protocols are just one aspect of network routing, and network administrators need to carefully configure and manage them to ensure efficient and reliable routing in their networks. Proper network design, planning, and configuration are essential for optimal routing performance, and it's important to choose the appropriate routing protocol based on the specific needs and requirements of the network. Inter-VLAN routing. Inter-VLAN routing refers to the process of routing traffic between different VLANs, virtual local area networks, in a network. VLANs are used to logically segment a larger network into smaller, isolated broadcast domains, which can improve network performance, security, and manageability. However, in order for devices in different VLANs to communicate with each other, a router or a Layer 3 switch is required to perform inter-VLAN routing. There are several methods to achieve inter-VLAN routing. 1. Router on a stick. In this method, a single physical interface on a router is used to connect to a switch that has multiple VLANs configured. The router is configured with subinterfaces or virtual interfaces, one for each VLAN, and each subinterface or virtual interface is assigned an IP address within the corresponding VLAN subnet. The router then acts as a gateway for each VLAN and performs the routing between VLANs based on the IP addresses. 2. Layer 3 switch. A Layer 3 switch is a switch that has built-in routing capabilities, allowing it to perform inter-VLAN routing without the need for an external router. Layer 3 switches have multiple VLANs configured with IP addresses, and they can route traffic between VLANs at wire speed, providing high-performance inter-VLAN routing. 3. Virtual Router Redundancy Protocol, VRRP, or Hot Standby Router Protocol, HSRP. VRRP and HSRP are protocols that provide redundancy and failover for routers. Multiple routers are configured in a group, and one router is elected as the active router that performs inter-VLAN routing, while the others remain in standby mode. If the active router fails, one of the standby routers takes over as the new active router, ensuring continuity of inter-VLAN routing. 4. Multilayer switches. Some high-end switches have built-in multilayer switching capabilities, combining the functionality of Layer 2 switching and Layer 3 routing in a single device. These switches can perform inter-VLAN routing without the need for external routers or Layer 3 switches, simplifying the network design and improving performance. The choice of method for inter-VLAN routing depends on factors such as the size and complexity of the network, performance requirements, redundancy and failover needs, and the available network equipment. Proper configuration and management of inter-VLAN routing are crucial for ensuring efficient and reliable communication between different VLANs in a network. Thanks for watching. For more information, like, comment, and subscribe our channel.